Now a few words about the complete basic functions. For the quadratic, we're getting the y values by squaring the x values. Doesn't matter what x value you use, you can square it. And when the x values get bigger and bigger, the y values get bigger and bigger, faster than the x values get bigger. So the curve keeps going up. And the complete curve then would be the extended parabola. It just goes on and gets steeper and steeper, and everything, the y values approach infinity. As x approaches infinity, they approach infinity faster. The curve keeps curving upward as you go this way and as you go this way. And we'll talk more about that terminology. Yeah. Okay. The exponential function, again, it just keeps doubling. The y values keep doubling. Every time x increases by 1, y doubles. So if we go out to x equals 3, it's going to be all the way up here. Then if we go to x equals 4, this is the value. It's going to double. It's going to be off the board by the time we get to x equals 4. But the point is that it's going to get very steep. Now, as we go in the negative direction, remember that this is 2 to the x. And we're taking negative numbers. So if we go to negative 3, we get 2 to the negative third. Well, that would be 1 over 2 to the third. That would be 1/8. So the value would become half as great. We'd be twice as close to the x-axis. When we get out here to negative 3, get out here to negative 4, we're twice that close. And we go to negative 5, and I can't even draw the thing without having it look like it's inside the x-axis, because the x-axis is thicker than it really would be. So this graph approaches 0. It looks like it merges with the x-axis, but the x-axis is officially a line which has no thickness. It won't merge. The curve will not merge with the x-axis. It'll always stay some distance away from the x-axis, but that distance gets really, really tiny, really, really fast. So there's the extended basic exponential function. The extended reciprocal function, well, we have to extend out past 2. If we go to 3, the value of the function is going to be 1/3, then it's going to be 1/4, then it's going to be 1/5, and so forth. So if we extend it out here, by the time we're at 3, we're at 1/3, then we're at 1/4, then we'll be at 1/5, and we see that this function is going to approach the x-axis. But it's never going to get there, because no matter how big your number is, 1 over a trillion, if you can conceive of a trillion, very tiny number, but it's not 0, so you do have some separation between 1 over a trillion and the x-axis, which is at 0. Okay? And on this side of the axis, it's going to do a very similar thing. It's going to approach 0. It's never going to curve downward, so when you draw it, you know, you keep making it less and less steep here, and there's a tendency, and I did it too, almost did it, to curve it down here a little bit. It doesn't happen. Think about what's going on when you draw these. Okay? So we have that, and in fact, well, I'll do this one. Okay? Similar thing's going to happen over here, except of course you're squaring x, so when you get out to x equals 3, y is going to be 1/9. So it's going to get down here very close and get x equals 4, y is 1/16. and you're going to approach the x-axis, but never reach it. But you're going to approach more rapidly than you do up here. Not as rapidly as you do here, but pretty rapidly. And you can think about all that. So we're going to have points here, and this is going to do the similar thing. It's going to appear to flatten out and join up with the x-axis. You can't draw the x-axis thin enough that this won't join it pretty soon. At least you can't draw it in a way that's visible and have that happen. So we have this behavior. Now before I do the cubic function, which is pretty straightforward, let's observe that we have a horizontal asymptote here. Since I'm doing asymptotes in red, this is a horizontal asymptote. Horizontal because it's approaching a horizontal line. These are vertical asymptotes. Okay? So I could put the word vertical here. And I'll put it where it should be here, right before the word asymptote. Okay? So we have vertical asymptotes here and here. And we also have horizontal asymptotes here, 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 and here. And I don't have room to label these, but we know what they are. We have them here as well. Okay, so kind of important terminology. Okay, when these extend, this almost looks like it's vertical, but it isn't, because obviously we keep cubing numbers, bigger and bigger numbers, we get y values, it's going to be somewhere. It's going to get very steep, it's going to look almost vertical very quickly, and that would be the complete basic cubic function. Now things about the complete functions, well, we'll talk about that in a minute.